Today we're covering 3.9 related rates. And essentially what it is if you have two variables, then you want to get one, you want to find how changing one of them affects the change in the other. Okay, so the typical way is, it's best to just explain, just to show with an example here. The typical way of doing this is, it can illustrate with exercise 1A. If A is the area of a circle with radius r and the circle expands, find dA dt in terms of dr dt. Okay, so what you do is you find an equation involving the area and the radius, which everyone knows is area is pi r squared. Okay, so the area is variable and then the radius is variable. Okay, so think of those as both variables. And you take the derivative, of each with respect to time. Okay, so you take the derivative with respect to time. So over here we have dA dt. Okay, and then over here, because it's 2r, then we use the chain rule. So it's 2 pi r. So the derivative of r squared is 2r, but then times the inner function, which is r of t, so that's dr dt. Okay, and then so that's the answer right there. 2 pi r dr dt is the answer. Or in Webassign, I guess they just want you to put that part in there. Okay, so and that's what there is. So if you find, basically the way to do related rates is to find the equation involving the variables, and then take the derivative with respect to the variable that you want to, that's right here, the dt, or whatever it is, and then solve for one of these, solve for whichever you want. Okay, so part B, suppose oil spills from a retro tanker and spreads in a circular pattern if the radius increases at a constant rate of 2 meters per second. Exactly how fast is the area increasing when the radius is 23 meters? Okay, so we just go with this right here. And they're saying, well, what rate, how fast is the area increasing, right? And so that would be dA dt. And you're going to put in 23 for r. Okay, so that 23 goes in right here. And then you're going to put in, the radius increases at a constant rate of 2. So that's telling that dr dt is 2. So that means this part gets replaced with a 2. Okay, and so then let's see, 23 times 2 is 92. So 92 pi would be the answer there. Okay, any questions with any of this? So that's your basic related rates problem. Let's do some other ones. Let's do some more. So number 2, the length of a rectangle is increasing at a rate of 3 centimeters per second, and its width is increasing at the rate of 5 centimeters per second. When the length is 9 and the width is 7, how fast is the area of the rectangle increasing? Okay, so here you've got area, and here you have length, and then here you also have width. And we know, see, there's an equation involving those three, which is the area is equal to the length times the width. Okay, now this right here, the length is increasing at this rate, that's dL dt. and the width is increasing at a rate of 5. Okay, so that's dw dt is 5. Okay, and then dl dt is 3. Okay, so what you do is you take this equation just like we did the other one, and we take the derivative with respect to t, the other variable. So on the left we have just dA dt. Now the length and the width are functions of time. Each of those is a function of time. So you're going to use the product rule. The derivative of the first one, dL dt, times the second one, plus the derivative of the second one times the first one. Okay, so I just used the product rule to get those two terms, okay? Then I can plug everything in. Okay, so the dL dt is 3. This one is 5. dWt is 5, and dL dt is 3, while the length is 9 and the width is 7. So that's a 7, that's a 9. Okay, and so what is this? 21 plus 45. So that's 66 would be the answer. It increases at a rate of 66 centimeters per second. The area does, when the length and the width are doing this. Okay, so that's just another basic example of how this works. Related rates. Here's another example. So we have a plane flying horizontally at an altitude of 1 mile and a speed of 510 miles. It passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. Okay, so what we have is we have this radar station. I don't know, maybe that's not a good drawing. And then we have, and this is the ground here, and then we have this plane, which is probably not a good drawing either. So we have this plane here, and it's traveling this way. Okay, and it's going at a rate of 510 miles per hour. Is how fast the plane is traveling. And it is exactly 1 mile above the ground, flying horizontally. Okay, so find the rate at which the distance from the plane to the station is increasing when it is 2 miles away from the station. Okay, this right here is the distance from the station. It happens to be 2 miles in the instant that we want, but let's leave that out for now. Okay, just don't think about that right now. Let's let this distance right here be x. The distance from the station to here, will that be x, okay? And that will help us. Now, with the previous problems, what we did is we actually, so if you look at the previous problems that we did, we found, okay, so we want to find dA dt, right? And we found an equation A equals something. And then also the previous one, we wanted to find dA dt. We found an equation A equals something. Okay. Here, it's important to know what we want to find. Okay, what we're after is the rate at which the distance from the plane to the station is increasing. So I've labeled this capital D. So we want to know what dt is. Okay, that's what we want to know. We want to know how fast is this distance increasing when it is 2 miles away from the station. To do that, you don't necessarily have to find an equation in terms with d equals something. I mean, we could in this case, but it's easier actually to do this. Okay, so the distance, because this is the right triangle, the distance squared is x squared plus 1 squared. Okay, now we could take the square root. So we have d equals the square root of x squared plus 1, but that makes it harder. It just makes it harder, okay? And this is fine if we just do this right here. So this is good enough for our equation, okay? And so we go ahead and differentiate this with respect to t. And here it's going to give us 2d dt. And then over here we have 2x dx dt. Plus 0. The derivative, that's 0. Okay, now we can cancel these 2's. Yay. And bring this capital D to the left-hand side. So we've got d dt equals x over d dx dt. Okay, now dx dt, that is going to be this right here, 510. Okay, because the plane's traveling horizontally, so that the rate at which this distance changes is going to be 510. So that's good to know right there. Now, x and d are variables, but it's saying, but right now is where we put in the values that they are. So when the plane is 2 miles from the station, okay, so this would be d equals 2 right there. Okay, so what's going to happen is this is going to be 2. That's going to be 2. Of course, and like I said, the dx dt is going to be 510. Okay, now the x, when that's 2, then we have well, let me start this. So we have d squared equals x squared plus 1 squared, or just 1. But this is 2. So that's 4. So x squared is 3. That means x is the square root of 3. Okay, so that will go right there. When d is 2. Okay, and then right here is where we plug everything in. Okay, so then you plug those into the calculator, and let me just do that right here to make sure that we're fine. So the square root of, the square root of 3 times 510 divided by 2. Okay, so I get approximately 441.6 729 something. It says rounded it to the nearest whole number, so that would be 442. Okay, so the key here is that you don't necessarily need to have D equals in terms of that. We could go that route. We could have gone that route. We could have gone D equals the square root of that, or would you write it like this? And it probably would have, I think it would have worked out okay if we had done that. But there's no need to do that. You can do the problem without doing that. Okay. Any questions about that, by the way? Okay, let's move on to the next one, number 4. Two cars start moving from the same point. One travels south at 32 miles per hour, another travels west at 24 miles per hour. At what rate is the distance between the cars increasing 3 hours later? So you have one car that's moving south at 32 miles per hour. And then you have another car that's moving west at 24 miles per hour. Okay, and then we have the distance between them, right? Okay, so let's call this one y and this one x, okay? So d squared is equal to x squared plus y squared. There's an equation that involves them. And so now we take a derivative of this with respect to t. And again, this one's going to be 2d dd dt. And this is going to be 2x dx dt. And this is going to be 2y dy dt. Okay, and then the 2's are going to cancel. Also, I can bring this d to the other side of the equation. So this d I take to the other side of the equation, and I have x dx dt plus y dy dt. Okay, and oh yeah, I forgot to mention that what we're trying to find is at what rate is the distance between the cars increasing 3 hours later. This is dd dt. Okay, so that's what we're after, and so I have it. Oh yeah, I've got it right here. Okay, so up until this point, the important thing is you treat all of these, okay, the d, the x, and the y, you treat them all as variables, okay? Treat them all as variables. And then once you take the derivative, though, and you come down to having this, you know, you're trying to find what this is, then you plug in the numbers, okay? So the key here is that, okay, these are traveling at constant rates. The key here is 3 hours later. Okay, so if you're traveling 32 miles per hour for 3 hours, that's going to be 96. Okay, so that's plugged in. If you plug the numbers in here, this is going to be 96. This one, and that's 3 times 32. This one here, 24 times 3. So 3 hours later, that's going to be 72. Okay, so we'll take x to be 72, or you could take it to be negative 72. That's fine too. And then we'll take y to be, you take y to be 96, or you could take it to be negative 96 because it's negative, but it's easier just to put the positive number in. So this is 72 and that's 96. Okay. Then the next thing is this one right here. It's traveling south at 32 miles per hour. So that's dy dt is 32. And it's traveling west at 24. So that's dx dt equals 24. Okay, now here's the thing. If you want to make down to be negative, which sounds logical, right? So if down is negative, then that's going to be negative. But then this will also be negative. Okay. So it doesn't really matter, but you have to be consistent. And if you want to make down positive, then this is positive and that's positive. And so that's what I'm going to do basically. Okay. And then likewise here, if you make left negative, then that's going to be negative and that's going to be negative. So they're going to just cancel out right here, but you can just make them positive. Okay. And then finally, the distance. Okay, so d squared is going to be 72 squared plus 96 squared. Or d will be the square root of 72 squared plus 96 squared. Let me see if I can figure that out really quickly with my calculator. Okay, that turns out to be 120. Oh, nice. So this is 1 over 120. And in the end, we get, it turns out to be 40 in the end, if you work everything out. Yeah, that's all 40. Any questions about that? Okay, let's move on to the next exercise. Number 5. Okay, so we have a water trough that's 10 meters long and has a cross-section in the shape of an isosceles trapezoid. It is 20 centimeters wide at the bottom, 60 centimeters wide at the top, and has a height of 40 centimeters. So it looks something like this. Although this is probably way off. Okay, so this is, it says 20 centimeters wide at the bottom and 60 centimeters wide at the top, and has a height of 40 centimeters. Okay, so that's what we're dealing with right here. I guess that if you were to come up here straight, then this should also be 20, I suppose. Yeah, because if the whole thing is 60, if the whole thing all the way across is 60, then that means it's going to be, we're going to have 20, 20, 20. Okay. And then this is 40. Okay, so that means that's 40 also, by the way. Okay, so the trough's being filled with water at the rate of, is being filled with water at the rate of 0.2 cubic meters per minute. So that's going to be dV dt. Okay, now one thing that you should be careful with is that this is meters and this is centimeters, right? So that's going to be a problem unless we do something. So we can either change this to centimeters cubed per minute, or we can change this to meters. And this is meters also, 10 meters, 10 meters long. Okay, so this is just a cross section, and then it's like going 10 meters like in that direction. Okay, so that's meters. This is meters. These are centimeters. So what I chose to do is change these to meters. So this is so the height is 0.4. So instead of 40, I used 0.4. Okay, and instead of 60, I used 0.6, and then 0.2. So I changed all those to points. Okay. Okay, so I'll get rid of these zeros because that looked kind of weird. Oops. Okay. So, so dVdt is 0.2. Okay, and then the question is, how fast is the water level rising when the water is 30 centimeters deep? Okay. And so that one, you can rephrase that one. Okay, so this part right here, how fast is when the water level is rising? So that would be, what is dH dt when h is 0.3? Okay, now, so the idea is that this is dV dt, and we want to know what dH dt is. And you can figure that out. So this is when the water level is here at 0.3. Okay, so that's maybe 0.3 right there. So what you need to do is come up with an equation involving the volume and the height. Okay, now the easiest thing is you could probably figure out the volume in terms of the height. Okay, so first of all, what I want to do, I want to come up with, first of all, what could be easier to do is to come up with an equation for the area. Okay, so what is the area? And then we'll just multiply that by 10 to get the volume. So we're looking for the area as a function of time. No, not time, as a function of height. Okay, so if you have a certain height of water, what's this area right here going to be? So that's the idea right there. Okay, so so what we need to do is come up with how long is this part. So as the height varies, what is this in terms of height from here to here in terms of this height? What is this distance going to be? Okay, and the answer is that as you go is that it's going to be this this distance here is going to be 0.2 plus whatever the height is, because you can see when the height is 0.4, then it's 0.2 plus 0.4. Okay, so it's kind of a linear thing like that. And when it's here, it's going to be just 0.2 plus 0. Okay, so here it's 0.2 plus 0 is this distance. This distance at the very top is plus 2 plus 0.4, which is 0.2 plus the height. Okay, so that's going to be 0.2 plus that. Now the area of a trapezoid like this is going to be the height times the average of the two the area of a trapezoid is going to be the height times the average of the lower and upper lengths. Okay, so let me just kind of, so if this is L1 and this is L2 and this is the height right here, then this area is going to be the height times L1 plus L2 divided by 2. Okay, so that's what I have right here. Or this is, yeah, so this is L2 and this is L1. Okay, so L2 is the upper one, L2 is the lower one. Okay, so that means that the volume, because it's 10 meters long, then you have 10 times h times this, which is 0.4 plus h all over 2. Now this 2 and the 10 reduce to a 5, like that. And the volume, then you distribute that right there. So that's 5 times 0.4 is 2. 5h times h is 5h squared. Okay, so now we have an equation that relates the volume with the height. So now we take the derivative. This becomes dv dt over here. This one becomes 2 dh dt. And this one, you have a 2 come down, so that's 10h. And then by chain rule, that's dh dt times dh dt. Okay, so now what we do is we plug everything in, and we know that dv dt is 0.2, right? So that gets replaced with a 0.2. We know that the height is 0.3. So that gets replaced with a 0.3. Right there. Okay, so in the end, we have 0.2 equals 2 dh dt plus, and this is going to be 3 dh dt. These two combine to be 5. So 2 plus 3 is 5. And so dh dt is 0.2 over 5, which is 0.04. Meters per minute. Okay, any questions about this exercise? Okay, so there was a couple of questions on the homework. I want to get to that really quickly that people asked me through Webassign. The first one is assignment 3.4b, number 3. Okay, and the question is to find the derivative of this. 3x to the 6th plus 4x cubed, all to the 4th power. Okay, so what you're going to do here is you have an inner function, and then your outer function is x to the 4th. All this to the 4th power, or x to the 4th. So it's the derivative of the outer function, which is 4x to the 3rd evaluated at the inner function. Okay, so that 4 comes down, this reduces to a 3, and then you keep this right here. Then, okay, so this part right here, in other words, is f prime of g of x. Okay, that's all this right here by the chain rule. And then over here, you're going to have g prime of x, which is the derivative of this inside part, which is going to be, okay, so 6, bring the 6 down, that's 18, and reduce that by 1 power. Bring the 3 down, that's 12, x squared. Okay. And also all this is the derivative of the inner function, the derivative of this inner function. Okay, so that's just using the chain rule there. And then you can like factor stuff out. You can factor x's out of here, factor x's out of there. You can simplify this further if you want. But that's not, I don't think that's needed. I think it would accept this as the answer, although I'm not 100% sure. Okay, but anyways. And the person that asked the question is not here. But anyways, there's one other question that I'm going to go through. This is from 3.6b, number 8. Okay, so I'm just going through that exercise. So here you have the f. You're supposed to find the derivative and also the domain of f. Okay. Okay, so what we're going to do here is the chain rule, the quotient rule. So that would be low d high. So the bottom one times the derivative of the upper one, but the derivative is actually just 1, minus the upper one times the derivative of the lower one. The derivative of this is derivative, that's 1. Derivative of this is 1 over x minus 5. Okay, times the derivative of x minus 5, which is 1. And then that's all divided by the square of what's below. So divided by that. And then what you're going to do is you're going to get a common, because this is a complex fraction, we can't have a fraction, we can't have a numerator that has a fraction in it. So we'll multiply both the numerator and the denominator by x minus 5. Okay. And so that's going to give us just an x minus 5 in the times all this. In the denominator. And the numerator is going to be okay, so if you multiply this times x minus 5, then so this times this is going to give you x minus x squared plus 5x, and then this times this is going to be minus 1. Wait a second. Okay, I messed up. Oops. This is times right here. So this is times. Okay, so when I distribute it into here, it just gives you a minus x. Okay, and then this times this is going to be, this right here is x minus 5. And then this one here, this last piece is just going to be minus nx. And then here, you're going to have minus x minus 5 times the natural log of x minus 5. Okay, so I'm still confused. I'm sorry, this is plus. So that would be plus x. Because it's a minus, a negative, because this is negative. So it's a minus, but then this is also negative, so it's plus. Okay. So confusing. So one little part what I got became so confusing. Okay, so we have 2x minus 5 minus x minus 5 log of x minus 5 over x minus 5 times 1 minus the log of x minus 5 squared. Okay, so that's answer the first part. Now the second part is asking what's the domain of f, okay? So first of all, you can't take the log of a negative number or 0 either. So x minus 5 has to be greater than 0, okay? That means x has to be greater than 5. That's from this piece here. Okay, now the second part is you can't have a 0 in the denominator. So this can't be 0. Okay, which means that basically if you take this 1 over here and multiply by -1, you can't have this being 1. And that's going to happen when x minus 5 is equal to e. Okay, so that can't happen. So x can't be 5 plus e, and it has to be greater than 5 here. So you need both of these conditions, and you need that. So you can write that as going from 5 is less than that, so you're going to 5 to 5 plus e, and then union 5 plus e to infinity. So that's how you knock out, that's how you remove the 5 plus e from this interval here.